Alright, welcome back. Right now in our project, our obstacles cannot fall off the map. And that is because our triggers are stopping them. Once an obstacle reaches the edge of the map, it will simply switch directions instead of falling off the map. But on the other hand, there is nothing stopping our player object from falling off the map. As you can see. So, to fix this, we need to create barriers throughout our map in order to stop the player object from falling off. In our map, these coordinates are the limits of our map. So, for example, if you're at negative 21.3, then you're at the left edge of our map. On the other hand, 22.3 is the right edge of our map. Then negative 18.1 is the lower edge of our map. And finally, 19.1 is the upper edge of our map. Knowing these coordinates, we want to make it so if the player object crosses these bounds, it will snap back into the bounds. We're gonna do this by using a class called mathf. Mathf is an Unity class that contains a collection of math methods optimized for float values, which is also why the class is called mathf, with f standing for float. The specific method we're going to use is called mathf.clamp. This method works by taking a number and forcing it to stay within a given range. So this is the structure of our mathf.clamp. In this example, value is kept between min and max. If value exceeds min or max, it is snapped back. Considering how mathf works and what our bounds are, we want to use mathf to keep our player character or player object within these bounds. It will be much clearer when we are coding, so let's get back into our Unity editor. Alright, we're gonna do all of our work in this video in our player behavior script. So let's open that up. First, we're gonna create two more variables. The first is gonna be a float variable named clampx, and then we'll have another called clampz. We don't need one for the y-axis because our player object doesn't move in the y-axis, only in x and the z-axes. Now we're gonna fill these variables by writing the following: clampx equals to mathf clamp. Then we're gonna add our value, which is transform position x. Then we're gonna give our mean value, which is negative 21.3. So let's write that, negative 21.3. Then we're gonna add the maximum value, which is 22.3. Now we're gonna do the same for clamp z, mathf clamp, transform position z. Now our mean value is negative 18.1. Then our max value 19.1. Now all we need to do is create a check to see if our player object has crossed these bounds. We're gonna write transform position equals to vector3. Then first we're gonna add clamp x. We don't have a clamp y, so we're just gonna leave it as transform position y. Then finally we're gonna add clamp z. Let's save that and test it in our editor. Now we're gonna test the left edge. We can't fall off the map. Then let's test the lower edge, the bottom edge. This doesn't work either. Let's test the other two edges. The right edge also doesn't work. And finally the upper edge.